name is Dr. Esther Trufan, and in this video, I'm going to demonstrate how to determine the specific heat of ice. For this experiment, we're going to need a coffee cup calorimeter with a lid. And for me today, that will mean 2 nestled styrofoam cups and a piece of cardboard on top. Because this is thermochemistry, we're going to need to monitor the temperature. We will also need to know the mass of the water that we're using and the mass of the ice that we're using. We're going to approximate the volume of water that we add, so we will need a graduated cylinder. So for our materials, I'm going to need the ionized water, but then at the time when I need to add the ice cube, I will go to the freezer and take it out because I need to have the ice at the temperature of the freezer. So the less time it spends waiting for the experiment, the better. So the first thing that we're going to do is turn on our scale, tare it, place the styrofoam cup on top, record the mass of the styrofoam cup. Then we're going to add approximately 200 milliliters of water. I'll start with 100 milliliters first. And I have 99.8 milliliters. And for my second measurement, I have 99.1 milliliters. Combined, the mass of my 2 water measurements and the styrofoam cup is 200.27 grams. At this point, I am going to record the temperature of my water. This will take approximately a minute or so. Because the temperature of the water that I kept at room temperature is unlikely to be very different from the temperature of the room, it's not as important that I put the lid up at this moment. The temperature of my water is 21.9 degrees Celsius. At this point, I will extract the thermometer and I will go get my ice cube. Here is an ice cube tray with lots of ice cubes. I just need one of them. I will take an ice cube, place it inside the cup, and record the mass of the water and ice. It is 227.35. At this point, I know the mass of the cup with water, and that difference will give me the mass of the water. From the mass of the cup with water and the mass of the cup with water and ice, I can determine by subtraction the mass of the ice. And now I am done with my scale. The next thing is pushing my thermometer through the hole in the cardboard and monitoring the temperature change inside the coffee cup calorimeter. And at this point, we're simply waiting for the ice to melt. If the ice is melting and we're getting close to the under 5 or 3 degree temperature, and you can still hear the ice moving around, it is best to restart the experiment with either a smaller ice cube or a larger amount of water. And my temperature right now is 15.9 degrees Celsius. So it has dropped some, but there is more ice to be melted. It is best to check on the temperature change inside the styrofoam cups in regular intervals. So record the temperature every 30 seconds or every 1 minute and see at what point do you achieve the same temperature for an extended period of time. So if 3 measurements are consistently the same, that means that you have reached thermal equilibrium. And that mostly likely happened because all your ice melted or because there isn't enough heat in the water cooling to make the ice melt and warm up to its melting point. I still have a substantial piece of ice cube in there. And my temperature at this point has dropped to 12.0 degrees Celsius. You may swirl it occasionally, but just be mindful that if water splashes out or water splashes on your cardboard, that is water not available to provide heat for the melting of the ice. And the occasional peaks are acceptable, just don't leave the cardboard away from the top of the styrofoam cups. My ice cube is completely gone now. I just need to swirl my coffee cup calorimeter a little bit. This will ensure that my water is completely homogeneous, meaning the same temperature throughout, and I can record my final temperature. And my final temperature is 8.1 degrees Celsius. So with my initial temperature of the water and the final temperature of the water, I will be able to determine how much heat was released by the water, and that amount of heat was used to both warm the ice to its melting point, completely melt it, and then raise the temperature of the melted ice to the temperature of the water to achieve thermal equilibrium.